G'day everyone, how are you going? We're back in term 4 of year 11 methods at the moment. We did a test at the end of term 3 which was on our differentiation and applications of. I already went through this with my class, but I'm going to go through the test here. It's a good test to do, so watch along and hopefully you pick up a few skills that you maybe didn't have in the first instance. What do we got here? First question, differentiate. Pretty easy. Remember the rule is power out the front, lower the power by 1, so this 2 becomes a 1. X to the power of 1 becomes x to the power of 0, and anything raised to the power of 0 is just 1. So that's why that one drops through there. 1 mark either way. Part B. Notice the different notation. It means the same thing, doesn't it? dy dx means the same as f dash x or f prime x. What are we doing? Power out the front. Here it is. Lower the power by 1. And then I just tidied up a little bit. Did a little multiplication in here. No problems at all. Next ones. This here I would suggest you rearrange first. Okay? We can do the derivative on the bottom line, but honestly, bring it up to the top line, get yourself this, and then the same rule applies. Power out the front, lower the power by 1. The minus here will cancel with the minus coming out front to get me the 10. Lower the power by 1. Oftentimes people see this and they go, oh yeah, that'll become minus 1. To go from minus 2 to minus 1, you've actually raised the power by 1. So lowering the power goes to minus 3. Now, right up the top there it said, expressing your answers with positive indices. So this wouldn't have been a suitable answer. What I've got to do is do the opposite of what I did in the first step, bring it back down to the positive indices. Last one over here, this was a good one. Now, if you weren't good with your Pascal's triangle, then here you would have spent forever multiplying this out to get it. Pascal's triangle, if you don't know that, I'll do a video on it sometime. But essentially, this is the first thing raised to that power. The first thing raised to 1 less. The second thing raised to 1. 1 less again. 1 more. 1 less, 1 more. Okay? And then the coefficients 1, 3, 3 and 1, they come from Pascal's triangle. Okay? Or combinations as well. 3 choose 0, 3 choose 1, 3 choose 2, 3 choose 3. So a little bit easier if you knew this. We could get this, and then we do our derivative, y dash, power out the front, lower power by 1, etc. Once you got the first bit, the second bit wasn't so hard. Question number 2. Very good question. This is very common. I almost guarantee something like this will come up in the exam. Look at what I've done. I've picked the key points. I've picked the key points, turning points, points of inflection, and I've dashed them down. And look, I'm telling the marker what I'm actually doing with those. A turning point becomes an x-intercept. A point of inflection becomes a turning point. So I'm telling the marker what I'm doing. And in between, I'm writing what the gradient is. Now remember, the gradient on the original one tells me where it should be located on the second one. Okay? Can't fit it all on the screen at once, but you see, look, all positive, right? From here, all the way through to there, gradient is all positive. And look, it's all above the x-axis. Gradient is negative, it's below the x-axis. Gradient is positive, above. Negative, below. So you follow that through. And then when you do the second derivative, it's really just repeat the same process. Forget that one was even there. Repeat the process, pick your key points, bring them down, draw your graph. Only 2 marks for each one. Turning points got your 1 mark, x-intercepts got your 1. Sometimes they're worth 3 marks. The third mark would be for a smooth general shape linking it all together. Good questions to do to practice. Really shows your understanding. Question number 3. I like this question because we've got 2 variables going on here, A and B. 2 variables. Now to evaluate A and B, 2 variables, I'm going to need 2 equations. So the first equation I'm going to get, because I know that it has a stationary point. Stationary point means the derivative is equal to 0 at this point here. Now remember, the x value carries through from original derivative, second derivative. X values carry through. So when x equals 1, I will find a stationary point, meaning my derivative is equal to 0. So what have I done? I've worked the derivative, I've let the derivative equal 0, and then I've solved to get A. Because when I took that derivative here, the B part disappeared. Remember, B was just a constant. So B disappeared. So I got A, and then I'm going to use that point there in the original equation, but now I know A. So I can solve for B. Nice little question there. Part B. Use calculus to determine. Use calculus says, I've got to do a derivative somewhere to determine the nature of the stationary point at the point 1, 4. Well, I've already got the derivative upstairs there. I already did that. So I just need to work the second derivative. And then let the second derivative, or sorry, put 1 in for the second derivative. And if the second derivative is positive, that means I've got a minimum point. If the second derivative is negative, that means I've got a maximum. And then if the second derivative is 0, I might have a point of inflection. We've got to do a little bit more investigation there. Might be a horizontal point of inflection. Okay? Be careful with that one. Do a bit of investigation. Scientific.